Peter, you present the evolution of AI in 3 waves.
Right. So the 3 waves is not actually our terminology. DARPA, a year or so ago, gave a presentation, and they said, we are recognizing that we've had a second wave now, but we're looking at what the third wave is, the third wave of AI. So what DARPA means by that is the first wave is basically what's now called good old-fashioned AI. So it's basically all the stuff that's been done for the last 40, 50 years in AI, which is a lot of logic systems, expert systems, but it's all sort of really kind of quite mathematical and logical, what's been done. So the early chess playing systems would be that, and expert systems. It's sort of flowcharts and getting experts' opinions and encoding, turning them into code. So these are logic systems. Then the second wave really hit us like a tsunami about 6, 7 years ago. People had been trying to get neural networks to work, that basically at a very, very abstract level are more like our brain, with sort of neurons and axons, just components connected together, where you're not actually programming the system as such, but you're teaching it. So 6 or 7 years ago, there was a real breakthrough in that. This technology had been around for quite a while, easily 20 years or more. And they eventually figured out how they could use massive amounts of data, massive amounts of computing power, which had become available over the decades, to build really useful models. And this is the second wave, is basically, call it deep learning, machine learning, but it's all to do with big data, machine learning. And so when DARPA talked about the third wave, they said, well, this is not really the kind of intelligence that we need for applications, or that we really imagine AI should be able to do. So what is that third wave? And that third wave is about having systems that can actually learn interactively as they act, that can adjust to changing circumstances, that can actually reason, that can explain themselves, they can say why they're doing stuff. That aligns very closely with what we've identified as a cognitive architecture, something that is inherently has the architecture or the structure of our brain, the various cognitive components that our brains have that give us human-level intelligence. So those are the 3 waves, and DARPA recently announced that they allocated $2 billion over the next 5 years for additional research in that area. And of course, we've been working on basically the third wave for the last 15, 20 years. Our focus, though, had been on just natural language conversation, whereas DARPA's domain for the third wave would also include, vision and robotics, dexterity. Obviously, they're interested in having robots and autonomous drones and whatever, but that really can think,
figure things out.
Think and figure things out, and explain themselves. Why did you change course? Or why did you make this suggestion or whatever?
You talk about the ability to give an explanation, to explain yourself.
Correct, yeah. And second wave deep learning really can't do that. And it's one of the big problems they have. In fact, in Europe, the European Union passed some law, and I have no idea how they're going to enforce it, but they say that AI systems have to be explainable. That basically, if an AI system gives a recommendation to give somebody a loan or not to give them, or to deny a loan, it has to be able to explain why it did that. And with deep learning, machine learning, is completely impossible to do that. With the third wave, you do have, at least to the degree that we can explain what decisions we make, and we can't always. Some of the things are just sort of like gut feel. Oh, I don't know why I hired this person or why I didn't hire that person. And you might kind of make up an explanation, but you may not be sure, what it was. But ultimately, some reasons are that complex. There's so many factors that come into it, and ultimately it's just, well, on balance, no, I prefer this one to that one, And ultimately, yes, even third wave machines, even cognitive architectures will have some decisions that are just so complex that it's not practical to give an explanation.